All right, this is my derivation for the derivative of the arcsine of x. We can see the formula here, and so this is going to be my proof of that result. Instead of starting out with the arcsine, what I'm going to state, so we're looking at y is equal to the arcsine of x, and I'm going to rewrite that as the sine of y is equal to x. And then I want to take the derivative with respect to x of both sides. So I get d dx of the sine of y is equal to d dx of x. Again, I'm taking the derivative of x, I'm taking the derivative with respect to x, so this is an implicit derivative. So on the left side, I get the sine of y being the outside function, and the derivative of the sine of y is the cosine of y, and then the inside function is y, so I have to attach a dy dx, and on the right side I have the derivative with respect to x of x, so that is 1. If I solve this for dy dx, I will get that dy dx is equal to 1 divided by the cosine, which I will write as the secant of y. So there I have found the derivative of y with respect to x, but it's written in terms of y, and I would like to have it in terms of x. So if I go back up to the beginning, I have that the sine of y is equal to x, so if I imagine that as being part of a right triangle, where y is this angle, then the sine is x. The sine would be the opposite divided by the hypotenuse. And then the Pythagorean theorem would say that this adjacent side would have to be the square root of 1 minus x squared. So what do I have here? I'll just rewrite this, that dy dx is equal to the secant of y. The secant is the hypotenuse divided by the adjacent. Recall that the secant is 1 over the cosine, and the cosine is the adjacent over the hypotenuse. So if I take the hypotenuse, that's 1, and the adjacent is the square root of 1 minus x squared, then that means that dy dx is going to be 1 divided by 1, the square root of 1 minus x squared. And that proves the result.